Hi, welcome to Oracle CloudWorld and this session on Upgrade to Oracle Database 19c. My name is Daniel and I work as a product manager in the Database Upgrade, Migration and Utilities team. I'm here today to talk about AutoUpgrade and how you can upgrade your database to 19c. A few years ago, when we decided to create the AutoUpgrade tool, we went out there and we talked to a lot of customers and we listened to their requirements, what they ask for in order to build the ultimate upgrade tool. And we have it, it's AutoUpgrade. You can upgrade your database in many ways, but there's really only one recommended way, and that is to use AutoUpgrade. What better way of showing you how to upgrade your database to Oracle Database 19c than doing a live demo? Let's have a look at the environment variables. My database is called DB. If I query $v instance, I can see that the database is currently running 12.2, and the time zone file is of a fairly old version. First, I'll check the AutoUpgrade version. 22.4, that's fairly new, otherwise I could download a newer version from my Oracle support. And AutoUpgrade is fully backwards compatible. It can upgrade to lower versions as well. Let's have a look at the AutoUpgrade configuration file. The database is called DB, and I've specified the source and target Oracle home. I want to create a guaranteed restore point before the upgrade. I also want to upgrade the time zone file and recompile invalid objects after the upgrade. And I want AutoUpgrade to start right away. These are default values, so for simplicity I can simply remove them. Let's try to check the database for upgrade readiness. I'll start AutoUpgrade in Analyze mode. I can use the lsj command to see that it's currently checking the database. After a little while, the analysis completes, and I can find more details about the analysis in the summary report. Let's have a look. Check passed and no manual intervention needed. I can go right ahead and do the upgrade. So I'll restart AutoUpgrade. I'll use the same command line, but now I'm starting in deploy mode instead of analyze. That'll do the upgrade, including all the post-upgrade tasks as well. I can use the lsj command to see that AutoUpgrade is currently running the pre-upgrade fix-ups. After a while, I can repeat the lsj command. Now it's actually upgrading the database. And let me use the status command, and I'll specify here the job ID. That will give me much more details about that current job, including the location of the log files. Let me switch to a different session and head into that directory. There are many log files. Here we have the main upgrade worker log. I can do a tail on it, and it'll allow me to see all the commands that are being executed as part of the upgrade. Back in the AutoUpgrade console, I can use the lsj command again, but with the -a option, I can get the lsj command to automatically refresh, in this case every 10 seconds. So that's a pretty neat way of monitoring the progress of the upgrade. The upgrade needs some time to finish, so let's head back into the presentation. AutoUpgrade can easily fit into your organization, regardless of which database architectures you use. If you have only one database, that's very easy to upgrade with AutoUpgrade, but even if you have many databases to upgrade, it is equally easy. You have one configuration file, you put in multiple databases, and you just kick off AutoUpgrade one time. Using a central console, you can monitor the progress of all the upgrades, and it's very easy. And it doesn't matter whether you have non-CDB, entire container databases, or individual PDBs that you want to upgrade. AutoUpgrade can handle it all. It can also handle multiple platforms. You can have databases on Windows, Solaris, AIX, and Linux. Works fine with AutoUpgrade as well. And you can even combine it with some advanced features. If you have a PDB that you want to not only upgrade, but clone from a remote container database, you can do that as well. You can combine cloning with a refreshable clone PDB with upgrade, all packaged nicely into AutoUpgrade. And then we have DataGuard. I know many of you are using DataGuard. And the good news is that DataGuard and AutoUpgrade goes not hand in hand perhaps, but they are best friends. AutoUpgrade fully support DataGuard. If you have a database that is protected by DataGuard, AutoUpgrade will automatically detect it. It'll inspect your configuration, and it doesn't matter whether you're using the DataGuard broker or a manual configuration, AutoUpgrade will know and act accordingly. Everything that happens on the primary database host, that is taken care of by AutoUpgrade, and you have to take care of the tasks on the standby database. By default, when the database is upgrading, redo is transported to and applied on the standby database. Since the redo is continuously applied on the standby database, this ensures that you can go live faster after the upgrade because you don't have to wait for the apply lag to be closed. This complies with the recommendations from the Maximum Availability Architecture team. And the architecture or the concept looks something like this. This is a typical DataGuard setup. You have two databases, Boston and Chicago. They're running on the old release and you want to upgrade to Oracle Database 19c. You install the new home on both of the database hosts, and the first thing that you do is to create a guaranteed restore point on the standby database. This will ensure that your standby database is protected. Then you can shut down the standby database and bring it up in the new Oracle home. We don't touch anything inside the standby database. We just start it in the new Oracle home. Then we switch to the primary host, and now it's time to start AutoUpgrade. The very first thing that it will do is to create a similar guaranteed restore point that now protects the primary database. Now all the databases in your DataGuard environment is protected by a restore point. Then AutoUpgrade will restart the database in the new Oracle home and then start the actual database upgrade. Now changes are being made inside the database. Those changes are being recorded into the redo stream, which is sent to and applied on the standby database. So pretty soon after the upgrade has completed on the primary database, and when there is no apply lag on the standby database, you can go live on a database that is upgraded and also protected by DataGuard. This approach we call the MMA approach. But with AutoUpgrade, there's also a different approach that you can follow, which we call standby offline. You tell AutoUpgrade which method that you want to use by using the configuration file parameter called defer standby lock shipping. The default is yes, and then you will follow the MMA approach. But we also have the standby offline approach. The major difference between the two is that in the standby offline approach, we keep the standby database offline, shut down. And then when you are satisfied with the upgrade on the primary database, you can bring the standby database online, let it catch up with the changes from the primary database, and then you can go live. So it is a little slower than the MMA approach, but it offers you another level of protection by not only a guaranteed restore point, but also by having the standby database offline. Whichever method you choose, that is a matter of personal preference. Both of them works fine in AutoUpgrade and are fully supported. Next, we have RAC. And it is the same love story as with DataGuard. AutoUpgrade and RAC goes hand in hand, and it's fully supported, except on Windows. RAC on Windows is a little niche case, and we still need to do some polishing for upgrade on RAC databases on Windows. So for now, RAC databases on Windows are not supported. But for all other platforms, Linux, AIX, and Solaris, it works completely out of the box. You don't have to do anything specific, just start AutoUpgrade. it'll detect that it is a RAG database and then act accordingly, like for instance setting the cluster database parameter to false. With AutoUpgrade, we've made it possible to kind of make your upgrades of RAG databases even faster. We have this feature called distributed upgrades. And to understand how it can make your upgrade of RAG databases faster, let me illustrate that with an example. This is a classic upgrade of a RAG database. When we upgrade a RAG database, the parameter cluster database must be set to false. This means that the RAG database can be running on one instance only. And this is what you can see in this example. We have node 1, where the upgrade is happening. First, $root is upgraded, and then all the PDBs in batches in parallel are then upgraded. But look at node 2 in the bottom. It is just sitting there completely idle. We have changed that with distributed upgrade. First, we still have to upgrade the root container with cluster database set to false. But as soon as the root has been upgraded, we can then restart the database, set cluster database to true, and now we can start the RAG database on more nodes in your cluster. And we can then process more PDBs in parallel because we now have more resources. If you want to use this feature, it is very easy. Simply in your configuration file, you set distributed upgrade to true, and then underneath the hood, AutoUpgrade will take care of all the magic for you. We were very excited about this feature, so we set out to create a benchmark that could show us some numbers. We had a 2-node RAG database, 4 CPUs each, and a container database with 8 PDBs. We saw a 41% savings in the upgrade duration by using this distributed upgrade. If you have more PDBs, if you have more nodes to add to the cluster, you will see that it scales, perhaps not linearly, but it will scale very good. Eventually, you might run into some contention issues in the root container, but I do expect you will see some pretty good numbers if you have more PDBs or more powerful systems. Now we can talk about scripts and how you can customize the upgrade workflow. I love upgrades, but I also understand that the upgrade of the actual database, it is just part of the show. It is just part of the things that you must carry out in the maintenance window. And this is where you can use scripts to customize the workflow. This is a typical example. In the middle, we have AutoUpgrade that is upgrading the actual database. But when you look in the documentation, we recommend, for instance, that you do a level 0 or at least a level 1 backup before you start the upgrade. You would want to start that before the upgrade. In your monitoring tools, you probably also want to set a blackout. You might want to notify the operations team, and you have one or more applications that are using that database. And those applications must be shut down gracefully. Likewise, after the upgrade, we also recommend that you do a backup. If you are using RMAN and you have RMAN catalogs, before you can start a backup in the new release, you must upgrade the catalog. You also want to get rid of that blackout that you created, and then you can restart the application. All those tasks are important, and they are a part of the upgrade project. With AutoUpgrade, in the configuration file, you can specify a script that runs before and after the upgrade. On Linux or Unix systems, you can specify a shell script. On Windows, you can specify either a batch program or a PowerShell script. And for all platforms, you also have the possibility of specifying a SQL script. So simply in that script, you put in all the commands that you want to execute. At best, if that script can return an error level to AutoUpgrade, depending on whether or not the shutdown was a success or the post-upgrade task were a success, AutoUpgrade can then react on that error code and hold the upgrade if, for instance, some of the pre-upgrade tasks didn't complete as expected. We also have to deal with initialization parameters. Overall, it is our general recommendation that you stick to the defaults when it comes to parameters as close as possible. The fewer parameters you need to specify in your database, the better. In Oracle, we have many databases that run, but most of them are running on the default configuration or very close to the default configuration. If your specific database has a very exotic combination of a lot of parameters, chances are that you are sailing into uncharted territory, and you might have a database that runs on a completely unique combination of parameters, and you don't really want to go there. So during the upgrade, that's a very good opportunity to get rid of some of those parameters. It might also be that your testing reveals that you need to change some parameters in the new release or possibly add new ones. In AutoUpgrade, that's very easy. You simply specify a list of parameters to add, change, or remove, and you can then reference that list in the AutoUpgrade configuration file. AutoUpgrade can remove, add, or change parameters either before, during, or after the upgrade. Now, some of those parameters that you have in the database might be undocumented parameters or underscore parameters. And there might be very good reason for using underscore parameters, but when you introduce an underscore parameter, you should also develop a plan on how you can get rid of that parameter, either via a patch or when you eventually upgrade. If you introduced an underscore parameter to solve a specific bug in a previous release, you might want to get rid of that underscore in the new release if the bug has been fixed. Since we encourage you to get rid of the underscore parameters, has introduced a configuration file parameter that makes this very easy. Simply specify remove underscore parameters equals yes, and AutoUpgrade will simply wipe out all the underscore parameters from your SP file as part of the upgrade. Now, we don't force you to do this, so the default is no. AutoUpgrade will leave your underscore parameters in there, but we want to make it easy for you to get rid of them. We want to encourage you to do it. And the same actually also apply with events. There's not a dedicated config file parameter for that, but you can add them into the list of parameters that you want to remove as part of the upgrade. Then the final parameter that I want to talk about is compatible. Our very clear recommendation is that you don't change compatible as part of the actual upgrade. You should wait 1 or 2 weekends before you change the compatible, because if something happens on the new release, it'll allow you to downgrade to the previous release and then resume operations there. However, changing the compatible parameter requires downtime because it is a static parameter. The database must be restarted. So in some organizations, taking an additional maintenance window is not possible. And in that case, you need to change compatible as part of the upgrade. That's also easy with AutoUpgrade. There's a dedicated parameter for that in the configuration file called raise compatible. Set it to yes, and AutoUpgrade will then raise compatible to the default that you're upgrading to. When you're upgrading to Oracle Database 19c, it'll be 19.00. Now, the database won't allow you to raise the compatible setting if there is guaranteed restore points in the database. So in order for AutoUpgrade to raise compatible, you also have to note in the configuration file that it is okay for AutoUpgrade to get rid of those restore points after a successful upgrade. The final thing that I would like to talk about is encryption. With cloud adoption, and today there is an increased focus on security, so encryption and TDE tablespace encryption is becoming more and more popular. Good news, AutoUpgrade and encryption works fine. You can upgrade encrypted databases and you can convert non-CDB databases to the new multi-tenant architectures, even if they are encrypted. If you look underneath the hood and look at the commands that AutoUpgrade are executing, you can see why AutoUpgrade in some situations must have the database key store password. Look, for instance, on the create pluggable database statement. There is a clause where you need to specify the key store password in order to make certain changes to encrypted databases. Now, the database key store password, that is sensitive information. When you provide the key store password to AutoUpgrade so it can use it later on, AutoUpgrade must have a safe way of storing that password. There are 2 ways where AutoUpgrade can handle that. Either it can use a secure external password store. That's a feature inside the database where the database can store the key store password for later use. If you have configured such, AutoUpgrade will detect it automatically and use it. If not, you, as an operator, can supply the key store password to AutoUpgrade, and then AutoUpgrade can store that password in its own key store, and then it can safely retrieve it later on when it's needed. When you're working with encrypted databases, there is one important configuration file parameter that you should set: global.keystore. It specifies the location in the operating system where AutoUpgrade can create its dedicated key store. When you look in the operating system, you will see that it is a software key store. There's a file called ewallet.p12, and it's very similar to the one that you can find in the database. We're actually using the same functionality. Since it is a key store, and since the key store holds sensitive information, you should protect that directory in the operating system as you would with the database key store. Once you have specified the location of the key store, you can analyze the database. AutoUpgrade will connect to the database and investigate whether or not it is required for you to input the database key store password. If that's the case, you can simply look in the summary report. It'll tell you very nicely whether or not you need to input database key store passwords and for which of the databases in your configuration file where it's actually needed. Now let's have a look at the upgrade and see how far it is. Okay, the upgrade has been running for a while now. I'm pretty sure it'll finish soon. Whoop, there we have it. Job 101 completed. The database has been upgraded, including all the post-upgrade tasks as well. A good reminder here, remember to drop the guaranteed restore point at a later point in time. Let's connect to the database and verify that it has been actually upgraded. Looks good, 19C. And the time zone file is now upgraded to version 39 as well. When I'm satisfied with the upgrade and I know that I don't want to roll back, I can drop the guaranteed restore point that AutoUpgrade created right before the upgrade. And that's it. Thank you for attending this session on how to upgrade to Oracle Database 19C. My name is Daniel, and I hope that you enjoy the rest of Oracle CloudWorld. Thank you.